In this next example, we're going to talk about how to use the alternate definition of a derivative. The main difference between this definition and the previous definition is we're not letting the limit as h approaches 0. Instead, we're letting the limit of x approach a number. So this definition is the definition of a derivative at a specific point. So this is used if you want to find the derivative at a point right away, rather than finding the function for the derivative and then plugging in that x value. Either definition can be used to determine a derivative. However, for some more complicated functions, sometimes it's easier to plug in the value right away instead of having to work with different values of x. So example 2, we're going to use the alternate definition of the derivative to differentiate f of x equals the square root of x at the point x equals a. So wherever we see an x, we're simply just going to put an a. So here we have f prime of a is equal to the limit as x approaches a of f of x minus f of a, all divided by x minus a. So our goal here is to plug in a for x. But right now, if we were to do that, you would get f of a minus f of a, which would be 0, and you would get a minus a in the denominator, which would also be 0. And so you get 0 over 0, which doesn't tell us anything. So what we're going to rewrite this as the limit as x approaches a, and f of x is the square root of x, and f of a is plugging in a for x, so it would be the square root of a, all divided by x minus a. And again, plugging in a, I would still get 0 over 0. So whenever you have a square root, the typical thing to do is multiply by the conjugate. So the conjugate of the numerator is the same thing with an opposite sign. And so now when you multiply those, you're going to get the limit as x approaches a of x minus a divided by parenthesis x minus a, parenthesis square root of x plus square root of a. And now from here, you don't want to distribute, because if you notice, the numerator and denominator terms are going to reduce. And so we get this is equal to the limit as x approaches a of 1 over the square root of x plus the square root of a. And at this point, now we can substitute in the a value for x. So this a value is going to go right in there for that x. And you get 1 over the square root of a plus the square root of a, which is 1 over 2 square root of a. And so this means that the derivative at a is equal to 1 over 2 square root of a. So if a was 5, you'd be 1 over 2 square root of 5. If a was 10, it'd be 1 over 2 square root of 10. And so now if we look at this graph, where this is f of x equals the square root of x, and we were to use this equation, which is the equation of our derivative, all you would have to do is pick any point a and plug it into that x value to determine the slope of the tangent line at a specific point. So now on your own, I want you to try to use the alternate definition to determine the derivative at a specific point. So I'm going to give you that f of x is 1 over x, and I'm going to tell you a is 2. And I want you to use the alternate definition to evaluate. So we have that the alternate definition is the limit as x approaches a of f of x minus f of a, all divided by x minus a. So just on the side, we have that f of x is 1 over x, and we have that f of a is 1 over a, so f of 2 is 1 over 2. And this is because a equals 2, so I substituted in for a. And so now we're going to write this as the limit as x approaches 2 of f of x minus f of 2 divided by x minus 2. So this becomes the limit as x approaches 2 of 1 over x minus 1/2 divided by x minus 2. And if we were to plug in 2 for x right now, we would get 0 over 0, which again we can't work with. So now I'm going to try to combine the numerators using common denominators. And we get this is the limit as x approaches 2 of 2 over 2x minus x over 2x, all divided by x minus 2. So we get this is the limit as x approaches 2 of 2 minus x all over 2x divided by x minus 2. And notice that these are almost the same except for a negative sign. So this is equal to the limit as x approaches 2. I'm going to factor out a negative from the numerator. And now what I can do is I can divide both sides by 1 over x minus 2. And it's going to make these reduce off. And I get this is equal to the limit as x approaches 2 of negative 1 over 2x, which is going to be equal to, when I plug in 2, negative 1/4. And again, this does not give you the equation for the derivative. It simply just gives you the derivative at a point. So this is f prime of 2. I want to try one more example. And this is number 7 from the homework. So we're going to try this as an exercise right now. And we have f of x is equal to the square root of x plus 1. And we're going to let a equals 3. So I want to use the alternate definition. So I want to use the limit as x approaches a of f of x minus f of a over x minus a. So right away I'm going to know that I'm going to need f of a is equal to the square root of a plus 1. So then f of 3 is going to be the square root of 3 plus 1, which is the square root of 4, which is 2. So right now I want you to try to solve this on your own and see if you can do it. Alright, let's try it out. So we get this is the limit as x approaches 3 of the square root of x plus 1 minus 2 over x minus 3. So again, we have to multiply by the conjugate. And so you get that the slope of the tangent line of the square root of x plus 1 at the point 3 is equal to 1/4. So if we have the graph like this, and we want it at 3, the slope of this line right here is 1/4.